Module 7, Introduction to Building Elements. Welcome back to the Revit M.E.P modular training series. Please subscribe to support growth of the channel. In this video, we're diving into Module 7, Introduction to Building Elements. This module is essential for anyone working in an M.E.P environment who needs to understand the surrounding building context. The purpose of this module is to introduce you to the placement of architectural and structural elements that support the M.E.P systems being installed throughout the rest of the training. In many real-world projects, you'll receive a Revit architecture or Revit structure model as the base for your M.E.P work. When that happens, the fixtures, fittings, and building elements you need are already in place and fully compatible with your project. But in other cases, the information provided might be only in 2D or in a non-Revit format, or in some situations, not provided at all. When that happens, it's important to understand how to model the basic building elements yourself so that the M.E.P services have the proper architectural and structural context. This module reinforces the principles we discussed earlier in model development methodology. We start by defining the major building elements: walls, floors, roofs, and ceilings, and we approach them using the same best practice workflow. That means our first step is simplicity. We begin by placing these elements as simplified geometric slabs using a single conceptual material, not complex composite layers. This approach allows us to focus on understanding the functional behavior of the elements, their shapes, their relationships, and how they interact with hosted components. Once the concept model is established with these Grade 1 generic components, we can later replace them with more detailed, composite, and manufacturer-specific system families, adding complexity only when the design decisions require it. Working this way creates a smooth path from early design through coordination and eventually toward fabrication-level detailing. During this module, we also introduce system family libraries and discuss how they should be managed and applied. You'll also learn the limitations that come with structural beams and columns when working in Revit M.E.P. And finally, we touch on an important feature introduced in recent versions of Revit, parts and assemblies, which allow walls, floors, roofs, and windows to be divided into separate pieces for tagging, filtering, scheduling, and exporting. We also highlight how Revit gives you the ability to add or modify the thermal properties of these building elements, allowing better integration with building performance analysis, heating and cooling load calculations, and GBXML workflows, which will be covered in future modules. By the end of this module, you will understand the different forms of walls available in Revit, including basic walls, composite walls, curtain systems, and stacked walls, along with how to place them and how wall constraints work at both the top and bottom. How to attach walls to floors, ceilings, and roofs, and how those attachments behave under different conditions. How to edit the elevation profile of a wall, including shaping the top, cutting openings, and creating voids. How to create floors, ceilings, and roofs using both manual sketch methods and the pick supports tools. The basics of roof design, including common shapes, slope methods, and overhang conditions. And finally, the different column types in Revit and how they behave, including the fundamental differences between architectural and structural columns. Module exercise. In this section of Module 7, we're going to apply everything we learned about building elements by completing a full hands-on exercise. We'll begin by inserting internal walls, then we'll create a floor slab, a roof, a ceiling layout, and finally develop a new system family style for walls. The exercise uses the Revit model named WFPRME07 Building A and will follow each step carefully from step 1 through step 46. The following steps should be done and read in conjunction with drawing number WFPRME07 Building B. Let's begin. Section 1, Walls, Steps 1 to 20. Step 1, open the starter file WFPRME07 Building A and switch to the ground floor plan. Step 2, zoom into the top right corner of the plan where the existing grey walls are located. This is the area where we will add new internal partitions. Placing new internal walls. Step 3. From the Architecture tab, under the Build panel, choose Wall Architectural. Step 4. In the Type selector, select Concept, int 150mm. Then, in the Options bar, set Location Line equals Wall Center Line. Drawing Wall A. Step 5. Using the default two-point drawing method, draw the first internal wall from point A to point B. This is Wall A. Drawing Wall B with listening dimensions. Step 6 and 7. Move your cursor along the top external wall near grid line 6. Revit will display a listening dimension back to the nearest wall face. Type 4500 to position point C accurately. Step 8. Now move your cursor downward vertically from point C until it intersects wall A at point D, splitting wall A to create an opening. Step 9. Split wall A on either side of grid line 5 and delete the inner segment. Don't worry about precise positioning yet, we'll adjust it. Dimensioning the opening. Step 10. Go to the Annotate tab and choose a line dimension. Step 11. First click the grid line as the reference, then click the two split wall ends. Place the dimension string near the opening. Step 12. Select the left wall segment and change the dimension to 750mm. Step 13. Now adjust the right wall segment to form a 1500mm opening. Placing additional walls. Step 14. Draw a wall across from point P to point Q. Then adjust its temporary dimension so the spacing is correct. Remember, depending on your Revit settings, temp dims may reference wall centers or faces. Step 15. Draw another wall centered on grid line 5 from point R to point S using wall offsets. Step 16. Change the offset in the options bar to 1350mm. Step 17. Click the wall intersection at point S, move the cursor to the right and type 2200mm. Step 18. Set the offset back to 0 and draw a wall from point T to point V. Mirroring walls, steps 19 and 20. Select the two newly drawn walls and choose Mirror. Pick Axis. Select grid line 5 as the mirror axis. This mirrors the walls to the opposite side, completing the internal partitions. This ends the first section of the exercise in the placement of internal walls. Section 2, Floors. Step 21. Navigate to the first floor plan. Step 22. From the Architecture tab, select Floor. Step 23. The default boundary tool is Pick Walls. Use it to select all the building's external walls. Step 24. Draw lines or arcs to define the stairwell opening exactly as shown in the reference drawing. Step 25. Ensure your floor boundary is a closed loop, then click Finish Floor. Step 26. Rivet will now ask whether you want to automatically attach walls to the underside of the floor. Click No. Automatic attachment often affects too many walls. Step 27. The next dialog asks if you want to notch the walls that intersect with the slab. Click Yes. Step 28. Use the type selector to set the floor type to concept 300 mm. Section 3. Roofs. Step 29. Go to the roof plan view. Step 30. From Architecture to Build, choose Roof by Footprint. Step 31. With defined slope turned on and overhang equals 500 mm, pick the walls on sides 2, 3, and 4. For side 1, use pick lines with lock enabled. Step 32. Select the sketch lines numbered 1, 2, and 4 and turn off Define Slope. Step 33. Select sketch line 3 and set its slope to 5 degrees. Step 34. Finish the roof, then switch to a 3D view. Select the 3 external walls beneath the roof and use the Attach Top/Base tool to attach them to the underside of the roof. Section 4. Ceilings. Step 35. Navigate to Ceiling Plans, Ground Floor. From the Architecture tab, select Ceiling. Step 36. Ensure the ceiling type is concept, 600 by 600 mm grid. Using auto sealing, click inside each room to place ceilings. Step 37. Revit automatically centers the grid in each room, but this may not be visually ideal. Step 38. In the room between grids B and C, rotate the ceiling grid 45 degrees using the Rotate tool. Section 5. System Family. Creation. Step 39. Close the previous file and open WFPRME07 Building B. In the 3D view, select an external wall. Step 40. In the Properties palette, click Edit Type, then click Duplicate. Name the new wall type New External Wall 1. Step 41. Click Edit Structure and build the wall composition exactly with the following layers: brick 102 mm, air layer 40 mm, insulation 45 mm, core boundary, layers above wrap, concrete block 100 mm, core boundary, layers below wrap, plasterboard 13 mm. Ensure the total thickness equals 300 mm. Step 42. Click OK twice to return to the 3D view. The selected wall now displays the new materials and finishes. Applying the new wall type, step 43, select any other external wall that is still concept, X 300mm, right-click and choose Select All Instances, then select an entire project. Step 44. In the Type selector, assign the wall type New External Wall 1. All external walls now adopt the new construction. Applying wall sweeps, step 45. Select the 3 low walls forming the flat roofed extension. Step 46. In the Type selector, choose New External Wall 2, which includes a brick plinth and coping stone as wall sweeps. These sweeps automatically miter at corners and cut around windows and doors. And that completes the exercise for Module 7. We placed internal walls, created floors, roofs, and ceilings, and finished by developing a custom system family for external walls. These steps form the foundation of building modeling in Revit M.E.P. and ensure that your services always have a reliable architectural and structural context. Thank you for your time. Please don't forget to subscribe to support growth of the channel in order for us to be able to produce more content like this. We'll see you on Module 8, where we'll be discussing and doing exercise on equipment, fixtures, and fittings.